Curie law. The first for paramagnetic substance. For the paramagnetic substance, when we put the paramagnetic substance in the magnetic field, then the intensity of magnetization I is proportional to the external magnetic field P. It is found experimentally, and it is also found experimentally that I is inversely proportional one by the. As the temperature increases, then the magnetic dipoles will be random. So the intensity of magnetization will decrease. If we combine these two, then I will be equal to some constant C multiplied by B beta T. So we can write B is equal to mu 0 into H. So here he put here. So chi will be equal to I beta H, and I is equal to C B0 beta T, and H and B beta B0 beta H, that is equal to mu 0. So chi is equal to C into mu 0 beta T. Or now C is Curie constant and mu 0 is the permeability of the vacuum. Both are constant. So we can write chi is equal to C constant divided by T. So this is the Curie law. So or this is the Curie equation. So Curie law says that for the paramagnetic substances, the susceptibility decreases as temperature increases, or susceptibility is inversely proportional to the temperature, which is expressed in absolute degree, absolute Kelvin. So chi is equal to C beta T, or chi is proportional to 1 beta T. This is known as the Curie law for the paramagnetic substances. So as temperature increases, the chi or the susceptibility will decrease. So temperature will increase, susceptibility will decrease. Now, if the substance is ferromagnetic substance, then for ferromagnetic substance, then we say that chi susceptibility is equal to Curie constant C divided by capital T minus Tc. Capital T is the temperature of ferromagnetic substance. Tc is known as the Curie temperature. So the chi will be equal to C divided by capital T minus Tc, that is the temperature of the ferromagnetic substance minus the Curie temperature Tc. Now what is the Curie temperature? Now as we increase the temperature, what will happen? For the ferromagnetic substance, the domains are there, and as we increase the temperature, the domains are split or say divided. So the susceptibility will decrease. As the temperature is equal to Tc, means when temperature is equal to the Curie temperature, at that condition the ferromagnetic substance will be converted into paramagnetic substance. So if the temperature is Tc, then the paramagnetic substance will be converted into ferromagnetic substance will be converted into paramagnetic substances. And here Tc is Curie temperature. Curie temperature is that temperature at which the ferromagnetic substance is converted into paramagnetic substance. So as T will increase, here also chi will decrease. So this is about the Curie temperature and Curie law for paramagnetic substance and ferromagnetic substance. Now, second is what is the hysteresis curve. Now, what do you mean by hysteresis curve? So, as we know that we have a sample, suppose this is the sample, and here we have a solenoid, and we pass the current here. Here is the arrangement so that we can change the polarity of the current. Means when this is here connected here, the current will flow by like this, and when it will connected here, then current will flow like this. So we can change the direction of current. By the help of the rheostat, we can vary the current, so magnetic field will be also changing. So first what we do, initially it is a ferromagnetic substantial plate, it is unmagnetized, means there is no magnetic field. So now at when current is 0, H will be equal to 0, the magnetic field is 0, H is 0. Now slowly we increase the current. Here we have a positive, we connect here positive and negative. So this end will be positive. So current will flow from like this. So now we will increase the current slowly. Then H will increase slowly. Then when we increase the H, B will also increase. And at this point it is increases by this curve. And at this point B, it is saturated. Means now by increasing the current or magnetic field, magnetizing field, the B will not changing, and this known as the saturated state. Now saturated state is that state in which all the domains of ferromagnetic substance, they are all aligned in the direction of external magnetic field. So further increasement of magnetic field B is not possible. If we increase the H, then it will be straight line. So B will not change. So this point will be the saturation point, where the value of the magnetic field B is maximum at this field. Now if we decrease it, now we decrease the current. Now first value we have increased the current, means we put it like that. Now we decrease the current, we will increase the resistance, so current will decrease. Now when we decrease, this curve doesn't retrace it. Original curve was when it was 0 and it increases. This was the curve AOA. AOAB. At B it is a saturation. So it was the current. But if we decrease the current here, means we are decreasing H, then what will happen? It will be decreasing. It will not retrace this path. It will take another path here, and at this point, see, the H is 0, but B is not 0. Now here the current is 0, when H is 0, but magnetic field is not 0. What do you mean by this? It means that if we are decreasing, we are changing the H, B is also changing. But when H is 0, B is not equal to 0, means the B, magnetic field, will be lagging by magnetizing field. Magnetic field B is lagging by the magnetic field. When magnetic field is 0, but B is not 0, so means it is still magnetized. At this point H was 0, but it was B is equal to 0. But at this point B is not 0, and this point is known as the retentivity. Means the magnetic field or magnetization is retained even though the current is equal to 0. So this point is known as the C point, will be the retentivity point. So now what do you mean by the hysteresis? Hysteresis is a property of magnetic field by which the magnetic field B will lag by the changing the magnetizing field H. So this property is known as hysteresis. Now at this up to this point, this is the positive, and now if we want to make it negative, so we will change this direction. Now this will be positive. Now the direction of current will be reversed. So current will be reversed. So H will be also negative. When we negative, then what will happen? The value of B is decreasing, slowly decreasing, and at this point D, when B is equal to 0, H is negative, and this OD, this is the measure of coercivity, or this force is a coercive force. So coercivity will be there when the magnetic field is negative, H is negative, and at this negative H, the magnetic field B is equal to 0. So this is the coercivity. Now again we increase the current. So the path will be like this, and suppose at point E point, again if situation is there, then it is become a saturated. But the saturation value will be same, but here it will be in the opposite direction. It is in the plus direction, then it is the minus direction. Now again we decrease the current. We decrease the current, then B will be decreasing, and at here this will be H is equal to 0, but B is not equal. So this is also a retentivity, and again we change the directions, and so this will be again positive. Here current is positive, and then it will be a trace, and again this will reach the point. So in this, one cycle is completed. In this cycle, from here to here, it is magnetizing, and here to here it is demagnetization. So this complete cycle is known as the hysteresis cycle. And in the hysteresis cycle, what will happen? There will be two functions there. One is the magnetization increases, means it is a magnetized. When it is a magnetized, in that case it will absorb the heat, absorb the energy from the source, and when it is demagnetized, then it will leave the energy, or the energy will be decreased. So it will be decreased in the form of heat. So here when it is charging, the energy is increasing, and when it is demagnetizing, then the energy is liberated, or energy is loosed. So energy is lost, and this loss of energy will appear as a heat. So in one cycle, now if we go for larger cycle, then again what will be there? For it is charging, discharging, charging, discharging, means it is a magnetized, demagnetized, magnetized, demagnetized. So there will be a gain of energy, there is a loss of energy. So there will be heating effect on the ferromagnetic substances. Here its temperature will increase due to the loss of energy, and loss of the energy will be appear as a heat. So it will be slightly heated for this. So ferromagnetic substances are divided into two categories. One is soft ferromagnetic substance, and another is hard ferromagnetic substance. Now if we draw the BH curve, and this is small curve, and this is for the soft ferromagnetic substance, and the example is your iron or soft iron. And here the bigger loop, the shape of loop will be same, but its shape will be more, its area will be more, its retentivity will be more, its coercivity will be more, and that is for the hard ferromagnetic substance, and which is the, जैसे we take the case of the steel. Steel is a hard ferromagnetic substance, whereas iron is soft ferromagnetic substance. Now first we will discuss what is the soft ferromagnetic substance. For the soft ferromagnetic substance, number one, the area of hysteresis loop is small. Or we can say narrow hysteresis loop. Low retentivity. Retentivity will be low. This will be very small. Then low coercivity. This coercivity will be also less. Then high mu. So B will be large. For the same, when H is 0, B is large. So the permeability is large at low H, when H is very small and permeability is very large. So these are the characteristics of the soft ferromagnetic substance. Number one, it's the area of the loop is very small or it is a narrow loop. Second, it has low retentivity. This point is low. Then there is a low coercivity, means it can be demagnetized easily, it can magnetize easily. So mu is more, mu is high, and H is low. When H is small, mu is high. So such type of ferromagnetic substance are soft ferromagnetic substance. Example is your soft iron. Now where are such ferromagnetic substances are used? Number one, in transformer. The core of transformer, we have a ferromagnetic substance. Then we can have the electrical bell, in the telephone, in the electrical motors, in the electrical dynamo. In all these, we require a magnet which is made up of the soft ferromagnetic substance. Generally, soft magnetic substance is taken either the soft iron or we can say permalloy. Permalloy जो है वह that is a 4% silicon plus iron. Then we can say mu metal. Mu metal is iron. It is a alloy of iron, nickel, copper and manganese. So these are the ferromagnetic substance, soft, and these two are used for the core of the transformer, which are the soft, or for general electrical bell, telephone, then we will use a soft iron for that. Now for the hard ferromagnetic substance. Now hard ferromagnetic is just opposite it. The area of the loop is more. So large loop or area of the loop is, hysteresis loop is large. High retentivity means it cannot be demagnetized easily, and if the magnetizing field is 0, then it is not demagnetized. Coercivity is high, means it cannot be easily demagnetized. Then so such are the properties. So the examples are steel, cobalt steel, carbon steel, then alnico. Alnico is the alloy of aluminum, nickel and cobalt. So these ferromagnetic substances are used for the permanent magnet, whereas soft ferromagnetic substances are used for temporary magnet, means they can easily be demagnetized and they can be easily magnetized. But hard ferromagnetic substance, whether it is a cobalt steel or carbon steel or alnico, then the magnetism produced, that will be a permanent magnet. So permanent magnets are used in galvanometer, in emitter, in loudspeaker, where the permanent magnets are used. We will use the hard ferromagnetic substance. When we use the temporary magnet, then we will use the soft ferromagnetic substance, just like soft iron or the pulverol or mu metal. Now, what will be the stations? As I told that in one cycle, the magnetic substance or ferromagnetic substance is magnetized and demagnetized. In magnetization, it will absorb the energy, and in demagnetization, it will lose energy. So there will be a net loss of loss. So lot of energy, that will be known as the hysteresis law. Now what is the hysteresis law? It is equal to the area of the hysteresis law per unit volume of the material per cycle. So what is the hysteresis law? Hysteresis law is a loss that will be equal to the area of the BH curve or hysteresis curve or hysteresis loop per unit volume of the material per cycle or in one cycle. Then we can say the energy loss will be equal to A is the area of this loop, V is the volume of the substance, ferromagnetic substance, and frequency multiplied by frequency, that is N. So we can write this is equal to A V into N. N is frequency, V is the volume, and A is the area of the loop. V is the volume of the material. So that will be low. So in T time, this is for one cycle, and in T cycle, the total loss will be, you multiply by the T, so it will be A into V into N frequency into T. So this will be loss in energy in T time, and this loss of energy will appear as a heat. So due to the loss of energy, it will be appear as a heat. So temperature will increase due to the loss of heat. So we know that in the case of the transformer, we flow the oil so that the temperature is decreasing. Oil is circulating so that the temperature of the transformer will not increase very much. So this is all about the, now we will take some numerical question. Then first numerical question, if BH, horizontal component of Earth magnetism, is equal to 0.25 Gauss, 1 Gauss is equal to 10 raised to minus 4 Tesla. So this will be equal to 0.25 into 10 raised to minus 4 Tesla. The angle of dip is equal to 60 degree. Now you have to find the total magnetic field and the vertical component. Now we know that the vertical component VV will be equal to BH tan theta. So BV will be equal to, now BH is equal to 0.5 into 10 raised to minus 4 into tan 60. So tan 60 is equal to under root 3. We will put the value. So 0.25 into under root 3 into 10 raised to minus 4. So 0.3 is equal to 1.732, and if we multiply it, it will be equal to 0.433 into 10 raised to minus 4 Tesla. So we can find the vertical component. Now what will be the total component? Now we know that horizontal component BH is equal to B cos theta. So B, total magnetic B will be equal to BH bata cos theta. So B will be equal to BH बटा cos theta. BH की वैल्यू पुट कर दिया, cos 60 is equal to half and it will be equal to 0.5 into 10 raised to minus 4 Tesla. So in this way we can calculate, we know only the value of BH and the dip angle, then we can calculate BV and total B. Example number 2. Now BH is given, horizontal component is given, that is equal to 0.22 Gauss and vertical component given is equal to 0.38 Gauss. Now we have to find the dip angle and total magnetic field. So we know that tan delta is equal to BV bata BH. Value of, we put the value of BH, that is 0.038 and BH is equal to 0.022, divided, it will be equal to 1.72. So this will be tan delta. So from the table we can find the value of delta and delta will be equal to 59.5 degree. So we know BB and BH, we just divided, that will be tan delta and delta can be found. Now total B will be equal to, since BV or BH both are perpendicular to each other, so B will be equal to square root of BV square plus BH square. We substitute the value. .38 square plus 0.22 स्क्वायर, इसको ऐड कर दिया, इतना आ गया और स्क्वायर रूट करके इसकी वैल्यू जो है वह 0.427 गॉस आएगी, जो कैलकुलेट आप कर लीजिए. नाउ नेक्स्ट एग्जांपल. नाउ इफ द susceptibility is given, it is chi m is equal to 2.7 into 10 raised to minus 4 Tesla. तो टेस्ला यूनिट आती थी इसकी. And we have to find the value of mu and mu r. We have to find the relative permeability and permeability. Now we know that mu is equal to mu 0 1 plus chi m. So mu 0 we know, mu 0 is 4 pi into 10 raised to minus 7. 1 chi m की वैल्यू पुट कर दे. So mu will be equal to म्यू आर निकाल दिया पहले, म्यू आर निकाल दो. म्यू आर इज इक्वल टू, म्यू आर विल बी इक्वल टू म्यू बटा म्यू 0 विच विल इक्वल टू 1 प्लस काई एम. सो म्यू आर विल बी इक्वल टू 1 प्लस काई एम. दिस विल बी इक्वल टू 1 प्लस 2.7 into 10 raised to minus 4. This will be equal to 1.3027. So this value will be equal to mu r. Now mu is equal to mu r into mu 0. So mu permeability of the material will be equal to mu 0 into mu r. Mu 0 is equal to 4 by 4 into 3.1 10 raised to minus. This is the value of mu 0. It is fixed. Multiplied by mu r. We multiply the value. We have to find it and we multiplied it. It will be equal to 12.56 into 10 raised to minus 7 Henry per meter. So ये इसकी वैल्यू आ जाएगी. Now next example, we are given the magnetizing field H is equal to 10 raised to 4 ampere per meter and magnetic moment is 10 and the volume of the sample is equal to 2.5 into 10 raised to minus 6 meter cube. So we have to find the value of I. We have to find the value of I. We have to find the value of B. So we know that B is equal to mu 0 I plus H. Now what will be I? I will be equal to intensity of magnetization. Intensity of magnetization is magnetic moment per unit volume. We know the magnetic moment is 10. Volume is this. We divide it. So 10 divided by 2.5 into 10 raised to minus 6. This will be equal to 4 into 10 raised to power 6. ये वैल्यू आ जाएगी इसकी I की. Now B is equal to mu 0. Mu 0 is 4 pi into 10 raised to minus 7 multiplied by I, that is 4 into 10 raised to minus 6 plus H 10 raised to 4. So if we multiply it, and we will get it is equal to 5.036. B will be found in Tesla. We can find it. Now the next example. Now magnetizing field H is equal to given is equal to 314 Oersted. Chi is given 6.8 into 10 raised to minus 5. And volume is equal to 25 into 10 raised to power minus 7 होगा, minus 7 meter cube. So we know that I is equal to chi into H. Chi is equal to I bata H. So I will be equal to chi into H. Now we know the value of chi is that is equal to 6.8 into 10 raised to minus 5. And we have to find H. Now value of H is given the Oersted. Now we will convert the Oersted into ampere per meter. So we go 314 multiplied by 10 raised to 3 divided by 4 pi. 1 Oersted is equal to 10 raised to 3 bata 4 pi. So we convert it here. 314 into 10 raised to 3 divided by 4 pi. तो यहाँ पर ये कैंसिल होकर के इसकी जो वैल्यू आ जाएगी ये आ जाएगी 25 into 10 raised to 4. So this will be the value of H. So I is equal to chi into H. So chi is equal to 6.8 10 raised to 5 into 2.5 into 10 raised to 4. So we will multiply and we will get the value of I. Now what will be value of M? M is equal to I. We know that I is equal to M bata V. So M will be equal to I into V. So M will be equal to I into V. I value we have found it and we multiply with the volume known and we will get this. Now what will be value of mu? Mu is equal to mu 0 1 plus chi. So mu 0 is 4 pi 10 raised to minus 7 into 1 plus chi is 6.8 into 10 raised to minus 15. Now this quantity is very smaller than this, so we can neglect it. So the value of mu will be equal to 12.56 into 10 raised to minus 6 Henry meter. So in this way we can find the value of I, we can find the value of M, we can find the value of B when H, chi and V is given. So this is the last topic of this chapter.